Hello everyone. Today we'll be studying the second unit of the strength of materials, that is simple stress and strain. Okay, so let's start. So first we'll try to understand which are the two types of bodies. Okay, first one is rigid body and second one is the flexible or plastic body. Okay, you can call it a deformable body, flexible body, or a plastic body. Okay, it might not be called as flexible body, but it is a deformable or plastic body. Okay, so what is rigid body? The body which doesn't go under any deformation while after the application of load. Deformation means change in shape or change in the size. Okay, that is called, or change in the length of its body. Okay, that is called as deformations. So when it doesn't undergo any deformations, change in shape and size on the application of forces, that body is called rigid body. Okay, the main thing about the rigid body is in the nature there is no such body which doesn't has any deformation after the application of load. Every body in the nature, when applied the load, there will be a deformations. If you can consider this as imaginary body. Okay, if you consider this rigid body as imaginary body. You might say some bodies might be rigid body. Okay, but it is not true. Why? Because the bodies, when applied with the force, there will be a some or the other deformations that is not visible to our naked eyes. They are such a small deformation that you are not able to differentiate the deformation, or you're not able to see that deformations. Such type of bodies are called rigid bodies. So we call it as a rigid body because we can't see the deformation, so we call it as rigid body. Okay, next is a deformable body. The body which goes under the deformation or change in the shape after application of the forces is called deformable body. Next, mechanical properties of metals. First one is the elasticity, the property by virtue of which the material deforms under the application of load and returns back to its original size and shape after the removal of load. Okay, that is called as elasticity. Okay, that is called as elasticity. Next, plasticity, the material in plastic state, okay, when applied with the loads, will go under the permanent deformations. Here it, once we remove the load, the deformations will remain as they are. It doesn't come back to its original shape and size. So such bodies which once applied the load will be under the deformations are called as plastic property of that metal. Next is ductility. Ductility is nothing but when a force is applied over a body, so that firstly in ductility the tensile forces are applied, so that we can draw it into thin thin longitudinal sections, or reducing the section of that body, and okay, along the longitudinal directions. Okay, like thin metal wires. Okay, or the wires, electrical cables, you can see the copper wires in it, right? Those are nothing but with the ductility properties applying by tensile stresses, okay, forces, we get those wires to this such a small diameter. Okay, that property of the metal is called as ductility. Next is brittleness. Brittleness, the a good example is the glass. Whenever there is a force applied over the object, okay, and due to the deformation of that object, due to the application of the load, that fails. The the material fails or the metal fails. Such type of metal or the body is called as brittle body. Okay, which is brittleness. You can say cast iron is also brittle object. Example. Next is malleability. Property of the material which permits to extend, okay, which permits the object to extend in all the directions and without rupture. That is also without rupture and roll into sheets. These steel sheets which are used for the structural steel members, okay, these are the plates that you get, right? These plates are uh, get into the sections by the property of malleability. If there was no property of malleability, you wouldn't get these sheets for the structural members. Okay, next is toughness, the property of a material which enables it to absorb the impact and the shocks. Okay, that is called as toughness. When we call the object is tough or the body is tough, when we apply the impact loads or we apply the when we apply the shock forces. Okay, when we constantly apply this cyclic loading over it, such uh, material is called tough material. Okay, that is a property of the metal. Next is tensity. What is tensity? The property of a material which enables the material to resist the shocks and impacts. Okay, that is called tensity. Next is hardness, the ability of the material to resist the indentations or the surface abrasion. Okay, that is called as hardness. You might ask, what is indentation, right? You might ask, what is indentation? Indentation is nothing but if you take a material and you try to mark over it, a punch over it, so that there is a marking to be done over that object. Okay, the resistance provided by that body for that mark, okay, that is called indentation, marking done over the body. If you take a clay sample and you try to peer it with the with some sharp object, you can easily prick it and make a uh, any signs or any indentations, markings easily. If you take a metal body and you try to take a sharp object and try to prick it, okay, there might be no marks. That resistance given by the body shows us the hardness. Okay, that is what hardness is. Okay, next is fatigue, the material which is subjected to the repeated cyclic loading. Okay, that and that also in opposite directions. The cyclic loading is happening in the opposite directions. Okay, that type of loading is called fatigue loading, or that condition is called fatigue. When these conditions comes, on which type of conditions, in which type of loading this condition comes, uh, in the when you are applying the wind load, okay, to the body or a build or structure where the body is moving through and fro, right? Cyclic flow is there due to the uh, pressure of wind. The structure is moving through and fro. That time, such type of uh, condition is called loading is called fatigue loading. It might also occur in the earthquake. You might say the building starts vibrating in two and four directions. Okay, in the cyclic manner. So that time the fatigue conditions come into action. The picture. Okay, next is stiffness, the extent to which the object resists deformation or in the response of an applied force. Okay, stiffness is opposite to the flexibility. Okay, if a body is flexible, when applied the load, the body will bend. Okay, in the opposite case, it is stiffness. On a body, you apply the force and the body doesn't bend or deform. The resistance that body applies to that load from the deformation, that is called as stiffness. You say, right, the person is very stiff or the object is very stiff, it is not moving. When you apply the force over an object and it's not showing the deformations or the movements, that is called as stiffness or the resistivity. Okay, that is called as stiffness. Okay, next, coming to the stress. Okay, what is stress? If you consider an object, okay, it has its own internal resisting capabilities, right? Every object in the nature has its own resisting capabilities, right? You might understand, you might know this. Okay, when you try to apply a force on any object, okay, and you're trying to make the object to have some deformations, okay, for that, the what the body does is it tries to resist that deformations to happen. Okay, when you try to apply a load over a body, okay, that time, and make a deformation in it, that time the body will try to resist that force to make any deformations. Okay, what the resistance given by the body is called as stress. Okay, whatever the force we apply, okay, to that, the body will resist that force by applying internal forces to the applied force, so that there is no deformations. Okay, then that type of force, that resistance is called as stress. Okay, then you might say that if body moves by application of the force, that means you are overcome that stress or that resistive force which is been applied by the body. If you are applying a force of 100 kilonewtons over a body, and the body is uh, resisting that force, but the resisting force capability of that body is 90 kilonewton, okay, then your force which you are applying is larger. Okay, so that the remaining net force is 10, because the extra force which are applying is 10, so the body moves by 10 kilonewton. Okay, the the resistance, the 90 kilonewton per meter square, okay, what the force is applied per unit area, okay, that force is called as, per unit area is called as stress. For certain area, not for any amount of area, for unit area, whatever the force applied by the internal body to resist the external forces, that is called as stress. Okay, in simple terms, in the definitive type, definitions wise, it is the force of resistance per unit area offered by the body against deformation is called as stress. Okay, the formula for the stress is denoted by this, denoted by the sign sigma, okay, is equal to P is the load in newtons and area in mm square. Okay, sorry, it's a mistake, it is mm square. Okay, it is mm square. Okay, and the SI unit for the stress is Newton per mm square, because if you see here, what is load? SI unit of load, it is Newton, and the SI unit for the area is meter square, right? So it is Newton per meter square. You can also write Newton per mm square, because the resisting area or the unit per area is a smaller digit, so we take it as Newton per mm square, right? And one more thing is 1 Newton per mm square is equal to 10 raised to 6 Newton per meter square, because 1 meter is how much equal to how many mm? 1000 mm. That is 10 raised to 3. But we are squaring here, right? So we have to square here also. So this 3 zeros will, if you square 3 into 2, it will become 6. So it becomes 10 raised to 6. Okay. So it is called as 1 Newton per mm square is equal to 10 raised to 6 Newton per meter square. And 10 raised to 6 10 raised to 6 Newton per meter square is equal to 1 mega Newton per meter square. Okay, 10 raised to 6 Newton per meter square is equal to 1 mega Newton per meter square. Okay, and what is this Pascal? If you consider an area of 1 meter square by 1 meter square, 1 meter by 1 meter, it is 1 meter square. Okay, and you apply a force of 1 Newton, then that it is called as Pascal. Okay, when you apply a 1 Newton of force over a area of 1 meter square, okay, that is called as Pascal. Okay, next is, there are different types of stresses depending upon the type of loading applied. Okay, the first one is the tensile stress. In this case, you are going to pull the object from both the directions of the body. Okay, this forces applied will be equal. Forces will be applied on the both the sides, this from here and from here, and this will be, the forces magnitude will be the same, but they are acting in the opposite directions. Okay, and it is trying to elongate, so it is called as tensile tension, right? Because you are trying to put a tension over that object. Okay, and the stress and the resistance offered by the section of the body in the against the increasing of the length. We are trying to pull it, so obviously the length will increase. So whatever the resistance applied by the body to resist the this increase in the length is called as tensile stress. Okay, in case of compression, we are trying to push the body from both the directions. Here also both are equal forces and in opposite directions. So here there will be decrease in the length. In tension it was the increase in the length. In compression it will be decrease in the length. The resistance applied by the body, okay, to the decrease in the length, that is called as compressive stress. Okay, next is shear stress. Whenever if there is a body, okay, and you will try to apply equal forces in different directions like this, right? A tangential forces you apply, right, at a tangent, okay. So what happens is there will be a shearing occurring along that weaker section, okay. The resistance by this body, okay, the resistance per unit area resistance by the body to that tangential force is called as shear stress. In the definition, the stress induced in the body when subjected to the two equal and opposite forces which act tangentially across the resistance section. This is a resistance section. Okay, this is your resistance section. Okay, okay. Whatever the resistance is applied by the resistance section, okay, for this tangential force is called as shear stress. Okay. Next, what is strain? Okay, this part we'll be studying in the next part. Okay.